Hello again, YouTube. I apologize for the lengthy interval between videos. I was having webcam difficulties, but obviously I've been fortunate enough to get those fixed. And now I want to transition from whether science is reliable, since I think I've established that it was in the last video, to what does science have to say about the age of the Earth. Well, science has several fields that speak about the age of the Earth, the first being continental drift. Continental plates move about an inch or two per year, with the exact speed and direction of motion being different for each plate. By the late 1960s, it was clear that this explained four things. 1. The locations of earthquakes. 2. The formation of mountain ranges and volcanoes. 3. The mid-Atlantic undersea ridge. And 4. The uplifting of seabeds to great heights. By projecting the motion of continental plates back in time, scientists calculate that about 180 million years ago, the plates fit together to form a single continent called Pangaea. This explains why Africa seems to fit with North and South America like a puzzle piece. The Pangaea model predicts, and geological studies confirm, that the west coast of Africa and the east coast of South America have similar rock layers with similar plant and animal fossils in the regions that were connected before the continental split. Next is the evidence from glacier layering. Layers are produced each year as snow falls and atmospheric dust settles. Most of the dust falls during spring and summer. In the uppermost layers, scientists can see thicker and thinner layers in a pattern that matches their records of the varying amounts of snowfall in recent decades. The layers further down are more compressed but are in agreement with the historical record. Climate changes are detected in glaciers layers hundreds of years old that match those from historical accounts such as the Little Ice Age in Europe during the Middle Ages. One glacier whose layers were measured in Antarctica dates back 720,000 years. Finally, there's the evidence from radiometric dating. Despite its controversy, radiometric dating is the most precise method for measuring ages. Carbon-14 is only one type of measurement. Inaccurate results are produced when incorrect assumptions are made or the wrong kind of rock is used. Scientists use over 40 different radiometric dating techniques, each based on a different radioactive isotope. Scientists can double-check their work by comparing results from different isotopes to make sure they are consistent with each other. Such double-checking can sometimes be done using multiple isotopes on the same rock. Rocks from one formation in western Greenland have had their ages measured more than a dozen times using 5 different radioactive isotopes, each with the same result of an age of 3.6 billion years. In his book A Matter of Days, Hugh Ross expounds further on the process of radiometric dating. He writes, "Radiometric clocks operate on the principle of half-life decay. Radioactive isotopes, nearly all atomic elements, exist as a suite of isotopes or atoms with the same number of protons, but with a different number of neutrons. Disintegrate through time, that is, they decay into lighter elements. So for example, plutonium-239 decays into helium-4 and uranium-235. If we start with 10,000 plutonium-239 atoms and wait 24,110 years, we'll have only 5,000 left. In other words, 24,110 years is the half-life for plutonium-239. If we wait 48,220 years, only 2,500 will remain. After 72,330 years, 1,250 will remain. After 15 half-lives, a total of 361,650 years, the entire sample of 10,000 plutonium-239 atoms will have decayed into lighter elements. The lack of naturally occurring plutonium-239 anywhere in Earth's crust is one reason geologists and geophysicists are convinced Earth must be older than 361,650 years. Geologists and geophysicists also find no Neptunium-237 with a half-life of 2.14 million years, no Aluminum-26 with a half-life of 720,000 years, no Iodine-129 with a half-life of 17 million years, and no Plutonium-244 with a half-life of 82 million years. The lack of these isotopes in Earth, or the Sun, or in meteorites persuades scientists that Earth and the solar system must be older than a billion years, which is the half-lives of these times 83 million gives us 1,245,000,000 years. More on the reliability from Hugh Ross. Accurate dates can be determined only for samples that are no younger than about 1/6 the half-life of the isotope and no older than about 6 times its half-life, unless you have a very large sample. Thus, carbon-14, with its half-life of 5,715 years, provides reliable dates with rare exceptions, specifically for the samples of once living material between 900 and 35,000 years old. Again, the bigger the sample we have, the better. The more a sample is contaminated by materials of different ages, the less reliable the radiometric date. Interestingly, heat, cold, gravitational impulses, vacuum conditions, and chemical environments have no significant effect on radiometric decay rates. Measuring past decay rates can be indirect and difficult for geophysicists, but direct and easy for astronomers, because they routinely observe objects millions and even billions of years, light years rather, distant. Astronomers directly observe radiometric elements as they were thousands, millions, and billions of years ago. The measured abundances of these elements show that radiometric decay rates have not varied through time. Well, what about a young Earth creationist response to this? Because obviously this does not fit with the theory that the Earth is only 6,000 to 10,000 years old. They might posit that radiometric decay has been greatly accelerated during the flood. Hugh Ross writes, squeezing several billion years worth of radiometric decay into the 13-month duration of the Genesis flood would have generated a pulse of energy intense enough to destroy the Ark and all its passengers. Either all of Earth's surface would have turned into molten rocks and mass, or the Earth's crustal plates would have been subjected to a sudden movement many hundred miles in extent. No life would have survived. Not even a hint of such an event appears in Genesis. Further, astronomers see no evidence of this event. As they look back from the light years of stars thousands of light years away, they see no discontinuity in radiometric isotope abundances. Further, the hypothesis can't explain why the radiometric decay measurements show Earth to be only 1/3 the age of the universe. And so with that, I think it is established that the Earth is billions of years old from a multitude of different approaches and scientific fields. And this coming from Christian sources as well, like Hugh Ross, who believes that the Genesis account matches the scientific evidence. So it's not the case that this is a plot to usurp the Genesis account from our society. These are people who accept the Genesis account and still accept this scientific evidence. Next, we'll look at the much more controversial evidence for evolution. Thank you for your time.